Hi guys, it's Mr. Stark here. So we actually have to hit the ground running pretty fast. We've got around 7 days to cover 13 days worth of material and labs and lecture. It's going to be kind of balls to the wall, but what I want to show you is a breakdown of a basic motor control trainer where you can simulate many projects on this trainer, including the very first project that's in Moodle. So what you've seen here, that's all wiring. It's a mess because I want you to be able to trace these wires out and see what's going on. So like all motor controls, really the topic is, what are we controlling? We are controlling a motor control apparatus, or something that would control the movement of a piece of machinery, equipment, and associated devices. And really what that means is we train ourselves on these trainers, and we could put a variety of components on here and simulate the sequence of operations of nearly any project that's in Moodle, which is our platform, or any project that I have created along the way, and I've created quite a few. But let's just kind of get to the meat of the matter here. So the first thing that you're looking at here is a terminal strip. Now, your lab may not have this exact same trainer. Waterbury, we have these. So if you're in Waterbury, you're going to be looking at a basic trainer like this, and we'll step up and move on to other more complicated stuff. But for now, if you're looking at this, this is a terminal strip. And on this terminal strip, you'll see that I've got a 24 volt power source, which is represented by the hot conductor and the neutral home, or the return path home. We're going to use red and yellow. You're also going to see I have another power source here that says it's 120 volts. Same thing. We'll use the dark conductor as the hot and the white conductor as the return path home. And the way these terminal strips work is this screw is directly connected to this screw above. So this screw is directly connected to that screw. And I've got a bunch of screws that aren't connected to anything. They're just there in the event that I need a spot to land and make a joint from one wire to the next. So if I had the 24 volt power source on, I would have electrons right here waiting for me to do something with that screw. So the terminal strip is basically kind of like acting like a wire nut, a place to land wires. And we do this often in motor controls. We have many terminal strips. That's what that's called. The next device that you're going to see that's essential to understanding the labs is a stop-start station. And how this works, we start the piece of equipment and we stop the piece of equipment. And it's got two screws that hold the cover on. I'll probably have the cover off most of the time until I'm ready to use it. And I like to keep my cover right next to the button enclosure, so I know that these two screws up here are the start button, and I know that these two screws down here are the stop button. We need two wires to make most actions happen. So we need to feed one screw, and whatever we're trying to turn on, we come off the other screw. Very similar to a single pole switch for turning on lights. So if I'm looking at this button only goes on one way. You can't put it on upside down. If you look, the top of the stop start actually says up on it. So you know that you got to be putting it on that way. I've got the first lab wired on this. I'll show you that in a second. Got another start stop button because we're going to be using that in future labs. And then over here we have a series of lights, red, amber, or yellow, and green, depending on if we want something to turn on for green light, turn off for red light, or maybe some sort of trouble or alarm or some sort of indication with a different color light. And the way these are all wired is if you come around the back, all these are wired the same way. I don't care what lab you're in. Each of these lights needs a neutral to go home. So if you look really close on this trainer, this white from this tab is connected to this white of that light, and then it's also connected to this white of this light, which we can typically do this in motor controls. It's okay to jump out the neutrals. You're going to find that a lot of labs, that's what we do. We jump out the return path home so long as it's the same voltage. And what that allows me to do is leave one terminal strip to pick up any path home because they're all jumped out. So you'll see I have a wire that's jumped off of this neutral to bring that path home, but it also jumps out the neutrals of the other lights. If we had a wire tied onto them, then they would also have a return path home. And it's using another terminal strip as well. So those are the components that we really need in the first portion of the lab. I'll talk about more later, but if we're looking at this lab for what it is, there's supposed to be 3 labs that are done in one day, which is very quick when you understand that it's only a couple wires per lab. And how this lab works is when you get back to the school, you're going to get a paper something like this to start you off. And in Moodle, the labs are already opened up so you can see this, but I figured it'd be good for me to show you this now. A start button that turns on a green light. L1 represents the feed. So if we really wanted to like make an extra note on here, L1 is where the electrons come from. L2 is going home. So that's your return path, or neutral in the case of real language. So the first lab actually has you two basic circuits, and there's only, you know, a couple wires. So if you look at motor controls, everything about it is bring the wire into a screw. This dot represents a screw. It's the first screw in the start button. So if I come over here to the start button, here's the start button. Here are the 2 screws that are associated with that start button. If I look, here is a wire going into the first screw. That wire comes from the source. My 24-volt source, we're using the red as the hot conductor. So what I like to tell my guys in the beginning is once you land that first wire in the lab, cross it off. That just lets you know that you hit this point. You've got that first wire connected to that first screw. Now what you've got left is you got to come off the second screw of that start button, and you got to get to that green light. So let's see how I did that in this lab. So I came off the second screw in the start button. I came through the top of my push button operator, which I have to because I won't be able to close the cover if I come off the side. And I trace this wire all the way around, and if you look, we'll turn it around. It's the red wire. Let's keep track of the red wire. This goes into my green light. I know this because I have a green wire coming off of it, which is connected to my green light, just like the lab shows. So if I come back around, and if I take a look, I have that wire landed from the second screw of the start button, and it goes into my green light. The path home, which is this wire, still has to be done. So let's take a look at that path home. I come back around to my terminal strip. Remember, the neutral is the path home. This green is jumped into this little loop of wire. So we need to get that home. So when I press that button, these electrons are going here and they want to come home. I got that blue wire representing my neutral, and I'll try to use that typically through the lab. So if you see blue, it's the neutral going home. So we trace that blue wire out. That blue wire comes all the way back to my 24-volt source. And remember, the yellow on this wire represents the neutral. So that made its way home. Basically, it's a simple switch circuit. The problem is when I put the cover on and try to actuate this, I put it on, snaps on nice. I hit the start, I have to hold the button. I'm holding the button. Once I release it, it goes away. I hold the button, light comes on, because I have a path complete all the way back home. I release it, light goes off. This button, this start button, because it's got a spring action, okay, I'm pressing it, it's like springy, that's called a momentary button, which means the moment you hit it, it works, but the moment you let go, the light turns off. Momentary means there's a spring action, and it's only the moment that you hit it. So there's the first lab. Hope you get it. I'll give you another video for the second one. I'll go a little bit slower, and maybe we'll talk about more components. See you at the next video.